I'm sorry that last video got cut off. So I am recording a third video, and this video will continue to talk about different type of sampling plans and also errors that can arise in the sampling process. So we mentioned cluster sample. Cluster sample is when you go to it's a convenience sample. It's like an area. We're going to say our class, the 35 students in our class, is a cluster. Those inherently have sometimes selection bias. The last type of sampling plan that I want to talk about is, is a systematic sampling. Systematic sampling differs from simple random sampling in that it follows some kind of system. For example, if we took a phone book and we said our sample is going to be every person at the top of every page. That is kind of random, but it's also according to a system, not quite actually random. Or if I counted all of the people at St. Francis, 1 through 1600, and I said take every 10th person, that's a systematic sampling, a little bit different than a random sample. Okay. So, kind of segue into the last conceptual thing in chapter 1, and that is the types of errors. Okay, the types of errors. So, if you will, think about overall the overall arching is there's two categories of errors: sampling errors and non-sampling errors. Sampling error is the easiest. Sampling error is errors that arise just because we didn't talk to everyone, just because we chose to take a sample. That's called sampling error. Can't really eliminate sampling error. You can decrease it by increasing the sample size, but there's always going to be some error, some margin of error. If you've ever heard like, hey, we think the popularity rating of the president is 40%, and maybe you see plus or minus 3%, that is the statistician trying to account for sampling error, right? We didn't talk to every man, woman, and child in the United States, so we say it's somewhere between 37% and 43%. That's me trying to account for that sampling error. If I sampled more, maybe that sampling error would be 40% plus or minus 2%. So I can reduce sampling error by sampling more. That's an important point. We can increasing the sample size will reduce sampling error. So sampling error is the first category. The second category of error is something known as non-sampling error. Non-sampling error is a little bit different in that they're more serious. This is a problem in our process. These are mistakes. Increasing the sample size does not reduce non-sampling error. It actually just perpetrates it more. Okay, just perpetuates it is the word I was looking for. So we're going to talk about three types of non-sampling error. So non-sampling error is the category, and we're going to talk about 1, 2, 3 different types. The first one is errors in data acquisition. Errors in data acquisition is errors that arise from you acquiring your data. If I'm taking a sample of the weights of college students, but I have faulty equipment, maybe I have a bad scale, maybe it's off by 8 pounds. Well, me sampling more isn't going to fix it. I have an error in data acquisition. If I give a paper survey and then I type it into Excel, well, there could be an error made, and that's an error during transcription. That's a type of error in data acquisition. It's a non-sampling error. If you give a survey that maybe is ambiguous, where people don't understand the terms, so they give you a response that's wrong because they didn't really understand it, or if it's a sensitive issue, that also falls under errors in data acquisition. Maybe you asked something sensitive and they didn't give you a real response because they were embarrassed to do so. That's an error in data acquisition. Errors in data acquisition is a form of non-sampling error. As such, They can't be reduced by sampling more. They're just perpetuated in our sample. The second type of non-sampling error is something called non-response error. Okay, non-response error is if the sample is not representative of the target population. When there are people that are part of the population that aren't part of our sample because they didn't have a chance of being selected. For example, if you do a phone survey, well, that automatically has non-response error because there are people in the United States, 6% of the people in the United States, that don't have access to a phone. So you're not going to ever represent those people with a phone survey. If you do according to a MSNBC or a Fox News poll of our viewers, well, you're automatically suffer from non-response error because there's people that don't watch Fox News that maybe you want to see, or maybe people don't watch MSNBC that you want to see. As mentioned earlier, response rate is a key parameter. Okay, it's a key parameter. What was the percentage of people that we asked and the percentage of people that completed our survey? Okay. The last type is just selection bias. Okay, selection bias is kind of like non-response error. It's just a bias in the survey. If I go to the gym at 3 p.m. and I say, I want to figure out the average height of male students at St. Francis, and I say, hey, I see, 15 dudes walking around on the gym floor. Let's measure them and use that to make an inference about the whole. That's a biased sample, right? Because it tends to be basketball players or volleyball players, which tend to be very, very tall individuals. So that is selection bias. So any kind of bias in our sample, I think you guys pointed out when we used our class as a cluster sample, you said, hey, Dr. Miko, there's going to be selection bias in there because we're all business students. We're all sophomores, juniors, and seniors. There's no first years in it. So any kind of bias can be problematic. Excuse me. So that is all the material. What I would like to do then, that's going to be tested on the multiple choice, is kind of review quickly all of the chapter 1 material. And I'm going to start at the beginning. So we talked about 2 branches of statistics. Descriptive statistics was the first branch. Descriptive statistics describe, summarize, or organize data in an informative way. Under descriptive statistics, we had 3 branches. We had graphical, displaying data as charts. We had numerical, displaying data as numbers. And tabular, displaying data in a table format. Descriptive statistics. The second type was inferential statistics. Inferential statistics was making an inference. I'm going to go to this slide. Inferential statistics is making an inference about a population parameter based on a sample statistic, inferring from a sample something about the whole or the population. And we introduced some terms when we talked about inferential statistics. And we did some exercises in this. Population and sample. Population is everything I'm interested in studying. Sample is a subset I draw. Parameters are descriptive measures of populations. Statistics are descriptive measure of a sample. The process of statistical inference is taking a sample statistic and making an inference about a population parameter. When we do that, a couple other terms are confidence level and significance level. Confidence level is a percentage of times that a thing will be right in the long run, an inferential technique. Significance level is a percentage of times it'll be wrong. Usually confidence level is in the 90s. Actually, it should be in the 90s. In the world statistics, it better be 90% or higher or we don't use it, okay? So if confidence level is 9%, significance level is 10%. If it's 95%, significance level is 5%. These always add to 1. The Greek letter 1 minus alpha is what we denote is the symbol for significance level. I'm going to go to one more thing. So the hierarchy of data, interval, ordinal, or nominal. This was kind of in the first video. We went through some homework about this. There'll be multiple choices on it. Identify data. If it's interval, real numbers, calculations are valid. We can go down the hierarchy. We can't go back up. Ordinal is categorical, but there's an implied rank. Nominal is categorical without an implied rank. Okay, so that's the hierarchy of data. The other things that we covered, where does data come from? That was just today's lecture. What kind of errors we can have. All of those things are potential multiple choice in our sample. So I'm going to go to, let's go to Business Analytics 311. And I'm going to do, let's do, I don't know, I'm going to take the quiz. And I'm going to do, I don't know, maybe 5 questions. Once again, I'm going to do a chapter 1 out of class quiz, which once again is due Wednesday at midnight. And I'm going to preview this, and let's take 5 questions, and you'll see what they're kind of like. It says the response rate of a survey is the proportion of all people who were selected but did not complete the survey. Okay. This is false because it says did not complete the survey. It's a proportion of all people who were selected and did complete the survey. So this is false, okay, because that's what a response rate is. A resort employs 3,500 managers and staff to ascertain their employees' opinions of pros health insurance plan. 350 employees are surveyed at random. The proportion of the 350 who favor the health insurance plan represents a parameter in this scenario. That is not true. The proportion of the 350, because it's about the 350, that's a sample. So the proportion would be a statistic, not a parameter. So that is also false. A descriptive measure that is computed from a sample is called remember, descriptive measures of samples are called statistics. Descriptive measures of populations are called parameters. A random sample of 100 students is taken at this university. It's found that their average GPA is 3.1. If this information is used to help estimate the average for all the students, if we're taking a sample statistic and making an inference about all the students, that is known as inferential statistics. Okay. Which of the following types of sample is almost always biased because of the nature of the group? Remember, we talk about cluster samples inherently have selection bias because of the way that they are taken. Okay. So anyways, you'll have 15, 20 multiple choice on these concepts. I'm not going to go through any more. I don't want to. That's enough. But anyways, I'm going to end this video. So you're going to watch 3 videos for class in lieu of class tomorrow. By Wednesday, you're going to take the out of class quiz. I'm going to give you a sample of that quiz, 10 questions of that same pool of questions in class on Thursday. As well on Thursday, we're going to do bar charts, pie charts, maybe line charts. We'll see how we go, see how crazy it gets. All right, I'll talk to you soon.